Okay. So here's some other examples I figured that we could think about for a bit. Actually, let me just do it with everyone. So let's suppose we have a bag of marbles. You know, there are 6 red marbles in it. There are 2 white marbles, and there's 5 yellow. And besides color, the marbles are indistinguishable. So here what's going to happen is you're going to reach into the bag and choose a marble at random. But you can't tell by feeling the marbles which one is which. You know, you can't tell by feeling the marble if it's a red one, if it's a yellow one, or whatever. But let's suppose you do choose one at random. What would the probability then of choosing a red marble be? Well, let's think about it. How many marbles are there altogether? There are 6 and 2 and 5. What is that? That's 13. There's 13 marbles altogether, right? So the idea is we're reaching into the bag and we pull the marble out and we record what color the marble is. So what's the probability then of choosing a red marble? Well, there are 6 ways we can choose a red marble because there are 6 red marbles in there. And we just said in total there are 13, so it would be 6 out of 13, as you can see. Not sure if I meant for everyone to try this out on their own, but I really want to go through it with everyone. But again, I will post a complete set of notes. For a white marble, it's really the same idea, right? You know, it's the same idea. Namely, that should be the word and. So just letting you know, not add. And so from here, for a white marble, right? Well, we know there are 2 white marbles, right? So there's 2 ways the event of choosing a white marble can happen. And how many marbles are there altogether? Well, there's 13. So if you're choosing one at random, the sample space is there's 13 outcomes. So it'll be 2 out of 13. Okay. Now what about the probability of not choosing a yellow marble? Not choosing a yellow marble. Well, what would the probability of choosing a yellow marble be? Well, kind of like with 1 and 2, similar reasoning. The probability of choosing a yellow marble would be 5 out of 13. 5 out of 13, right? There's 5 yellow marbles in there. But we don't want a yellow marble. We want the probability of not choosing that. So it would be 1 minus that. So 1 minus 5 out of 13, which is 8 out of 13. So that's what we would get. Note also that even if we did not use this, I guess, how do I say this, identity, so to say, that if you do the probability of an event plus the probability of its complement, you get 1. Even without using that, we should be able to figure out that answer. Because if you're not going to choose a yellow marble, what has to happen then? You have to choose a red or a white marble. Right? You have to choose a marble that's not yellow. Well, how many ways are there for that? How many ways can we do that? There are 8 ways because there are 8 marbles that are not red. Excuse me, yellow, not yellow. 8 out of 13. So just another way to see it. Okay. Okay, so any questions on this? Okay, let's do another one. So let's suppose, it's kind of a strange example, but let's suppose a test was given to a group of students, the grades, and for some reason we recorded the color of their shirt. was recorded and summarized below. Hypothetically, we're assuming hypothetically that everyone wore a shirt that only had one color on it. Again, it's kind of a strange example, I know, but it's just for practicing probability. So these are the grades, A, B, or C. This is the number of students that wore a blue shirt, a green shirt, and a red shirt. And of course, we're assuming that no one can wear more than one shirt. So each person only has a blue shirt or a green shirt or a red shirt and not more than one. All right. Well, what's the probability that a student chosen at random wore a blue shirt? Well, notice that with a blue shirt, how many kids wore a blue shirt? 8 of them got A's, 9 of them got B's, 12 of them got C's, right? That's 29 students. You know, you can't get more than one grade on a test. So there are 29 students in the class that took the test that were wearing a blue shirt. So there are 29 students that wear a blue shirt. How many students are there altogether? Well, hopefully you can see that that's 80. You know, 31 students got an A, 19 students got a B, 30 students got a C, and that's 80. So what would the probability be? It would be 29 out of 80. Okay, that's good. What about 2? What's the probability that a student chosen at random got an A? Well, how many students got an A? Well, from this column, we can see that 31 students got an A. And again, there are 80 students, right? So the probability would be 31 divided by A. 31 divided by A. Excuse me, 31 divided by 80. I think I said divided by A, I'm sorry, 31 divided by 80. Okay. What would the probability that a student chosen at random did not earn a B? Sorry, that should be a C. Let me fix that. Be C. That was a typo, sorry about that. So what's the probability that a student chosen at random did not earn a C? Well, I mean, you could consider that, but it's a little bit easier to determine how many students got a C. The probability that is the probability of choosing a student who got a C. It's a little bit easier to do that, right? Because from here, we have 30 students altogether got a C, and there are 80 students. So the probability of choosing a student who got a C is 30 out of 80. Well, then what would the probability be of choosing a student who did not get a C? It would be 1 minus that, right? The probability of something not occurring, of an event not occurring, it's 1 minus the probability the event occurs. So the probability of choosing at random a student who did not get a C, you do 1 minus the probability that a student chosen at random earns a C. And that turns out to be 50 out of 80. So, I mean, here it's not so bad. You could just add up, you know, the students who got a B and an A, and with the students who got an A. But again, here I'm just demonstrating how you can use this. No, not this. This. That's all. Are there any questions on this? We have about like 5 seconds left, so let's stop here. Okay. So again, there is homework and a quiz due Sunday. Don't forget that. So if I don't hear from you, I'll see you on Friday.